everyone, so carrying on with straight lines today. So there's two videos, there's this one and also the Corbett Maths video as well. So the Corbett Maths one's linked on Firefly, so go watch that first and that will apply to question 5 on the sheet. So if you want to watch that video then do question 5, then come back to this one. That's a perfectly good way to do it. If you want to watch both videos and then have a go at everything, that's fine as well. Okay, so what we're going to start off by doing, I'm going to go through a couple of examples of the questions, so they're different to the ones in the Corbett Maths video. So I'll do 2 examples of each sort and then I'll say which questions they're similar to on the sheet. So we're going to be looking for the equation of a line when we get given a point on the line and when we get given the gradient. So with this one we're given the gradient here, the gradient's 8, and we're told a point it goes through. And from that we need to find the whole gradient of the line. So we're going to start off, we're going to write y equals mx plus c. So basically what we're going to do is at the end we should have a value for m and a value for c, and then we'll have a line equation. So straight off the bat we know that the number in front of the x is always the gradient. So we can just write that one straight in. So y equals 8x plus c. So we've used up this bit of information and we've found one of our 2 unknowns. What we need to do now is find the other unknown. So what we're going to do is rearrange to get c on its own. So we've got c, let's rearrange. So if we minus 8x from both sides, we have y minus 8x equals c. And now we're going to use our second bit of information. So we've got coordinates there, so we know that y is 3, because the y coordinate there is 3. And we know that x is 2. So we've got minus 8 times 2. And that is equal to c. So we substitute this in, so we've got 3 minus 16 equals c. So that is minus 13 equals c. So now we've got our m, that was just the gradient. We've got our c, that is minus 13. So we've got our missing information. So our equation of the line would just be y equals 8x minus 13. So we've taken the form we had here, we've worked out m and we've worked out c, and that just gives us our value. So each of these bits of information tells us one of the unknowns, so the gradient, and then we have to rearrange to work out the constant at the end. So one more example of that, a little bit harder because we've got a fractional gradient. But again, I'm just going to write out a general equation of the line. So y equals mx plus c. And again, straight off the bat, we get told the gradient. So we can immediately substitute in minus a half. So we're going to have y equals minus a half x plus c. So we can tick that one off, we've used that information, that is it. So the thing we still need, we need to work out c. So that is going to be where our second bit of information comes in. So last time I rearranged to get c on its own. You can do it just by sort of substituting in, then rearranging, so I'll do this one in that way. So we've got y equals minus 8, so I'm going to substitute that in. So minus 8 equals, and then we've got x is minus 6. So we've got minus a half times minus 6, so that is the minus half x, and then we've got plus c, so that bit hasn't changed. So now we've got minus 8 equals, so minus times a minus gives a plus, so this is going to be plus, and we've got a half times 6, which is just 3, and then plus c, because this bit we haven't done anything with. Okay, so now if we take away 3 from both sides, we just end up with minus 11 equals c. So we've got our value of m, we had that right from the start. We've got our value of c, so that means we've got our equation. So we've got y equals mx plus c. We know m, we know c, so it's y equals minus a half x and minus 11. So that one is done. So basically each bit of information tells you one of the unknown things. So one of them tells you the gradient, one of them tells you the y-intercept. Okay, so the questions we've just been through, so question 7 on the Corbett sheet, question 8 are both questions of that sort. So with both of them, you're given the gradient, you're given a point on the line, and you have to work them out. Question 7 is a little bit easier because the point you're given is always on the y-axis. So straight off the bat, you can work out what the y-intercept is because it's just the coordinate. Question 8 are more like the examples that I've just done, where you're just given a random point on the line, you have to work from there. So question 8 is a bit harder. I'd recommend maybe having a go at question 7 to start with, and then when you've done sort of 3 or 4 of them and you're happy with it, have a go at question 8. But if you're feeling confident, want to start straight on 8, that is fine. Okay, so the second skill is, we kind of did this, we started to do this the other day. So it's finding the equation of a line given 2 points on the line. So the other day when we were looking at gradient, we were looking at how we'd work out the gradient when we're given 2 points. Well, with this, if we're working out the equation of the line, we need to work out the gradient first, and then it just becomes like what we did before. So if we work out the gradient, we've then got our gradient, that's all good. We can then just follow on in the way that we did before. When you've got a gradient, you've got a point on the line, we can work out the equation. So the first thing to do is work out the gradient. So we do that using our change in y divided by change in x. So m equals change y over change in x. So now let's have a look. So going from A to B, we can see that the y has gone from 5 to minus 15. So our change in y is minus 20. And our x value has gone from minus 3 to 1. So that's increased by 4. So that tells us our gradient is minus 20 divided by 4, which is minus 5. So if you imagine we've got our y equals mx plus c, this is a general line equation. We've worked out, our first thing, we've worked out the gradient. So we know it's y equals minus 5x plus c. So we worked out our gradient, and now what we've got is very similar to the first one, the first sort of questions that we looked at. We've got our gradient, we've substituted it in, now we just need to work out c. So what we need to do now is we pick either of these points, and whichever one you pick you'll get the same answer because they're both on the line. So we'll pick this one because the numbers are a bit smaller, it looks a bit easier to deal with. So if we've got y equals minus 5x plus c, and we're going to rearrange this to get c. So let's add 5x to both sides. So we've got y plus 5x, and that just equals c. So now let's substitute in our coordinates the x and the y value to work out what c is. So I've got y is 5, so we have 5 plus, and then we've got 5 times x. So if x is minus 3, we've got 5 times minus 3, and that is equal to c. So we have 5 plus, so 5 times minus 3 is minus 15, so 5 plus minus 15 equals c. So that gives us minus 10 equals c. Okay, so we've worked out c, we'd already worked out m before, so now we can just write y equals, so if mx, so we know that m is minus 5, so that'll be minus 5x, and then we've got plus c, so we know c is minus 10, so that'll be minus 10. So answer, y equals minus 5x minus 10. Okay, so last example from me. So it's another one similar to the one before, so if you felt happy with that first example, feel free to skip on and have a go at the questions. If you want another example, watch this one and then we'll see it's a similar method. So we've got our 2 points, and again, like what we did in the first example of this, we're going to work out the gradient first. Because if we've got y equals mx plus c, we've got 2 unknowns to get. You could, in theory, do it either way around, but I think it's easier to work out the gradient first. So let's work out the gradient. So we're going from the change in y, so m equals change y over change in x. So let's work out the change in y. So going from this one to this one, so going from 1 to minus 1, so that means the change in y is minus 2. Changing x, it's gone from 1 to 5, so that means it has increased by 4. So that means the overall gradient is minus 1/2. So just simplifying that fraction, we've got minus 1/2. So that means we have y equals minus 1/2 x plus c. Okay, so let's find y-intercept. So now we're going to pick one of the points and substitute in the coordinates. So again, let's pick this one because the numbers are nice and easy. It's 1 and 1, so it should be easy to substitute. So if we've got y equals minus 1/2 x plus c, let's substitute in. So we've got y as 1, so 1 equals, we've got minus 1/2 times, and then x, which is just 1, plus c. So anything times 1 is just itself, so we've got 1 equals minus 1/2 plus c, because we've just simplified this bracket down to minus 1/2. And then if we add 1/2 to both sides, so we have 3/2 equals c. Okay, so all we've done now is just added 1/2 to both sides, so 1 plus 1/2 is 3/2. So we've worked out c, we know our gradient, we've got all the information we need. So we've got y equals minus 1/2 x, and we've got our plus c, which is plus 3/2. So y equals minus 1/2 x plus 3/2. Okay. Right, so this section of the video applies to question 6 and question 9 on the core maths video. So, sorry, not on the video, on the task. So question 6 is a bit easier. So if you want to start with some of the question 6 ones, you can do, and then go on to the 9. But I think it would be good to have a go at both, because in theory both of them could come up. It's a tough topic and it's quite a long method, but if you can master this now, it's a lot less work when you revisit it next year.